everyone, my name is Joel Dunai and this is my official and unofficial network state exam solution. Now it's the 18th topic, which is about the routing. The purpose, basic function and realization of routing. Routing, so we are talking about the network layer, the third layer if we go from bottom to top at the OSI layer. Of course, the routing is quite important because the routers have their routing tables, and based on their routing tables they will forward the traffic to another network or to the destination immediately. So they are having the routing tables to calculate the best path, and basically that's the purpose, to calculate the best path and forward traffic from one network to another network, from one device to another device. That's the base of routing. Static and dynamic routing, advantages and disadvantages. It is really easy. Static routing does not use CPU that much bandwidth, so that does not use that. This does not use that much bandwidth. CPU, the path from source to destination is always the same, and I don't know whether we have something else. Advantages and disadvantages. Of course, this can be an advantage that we always know the path from a source to a destination. The disadvantage of the static routing, that it is hard to scale. It is only good for a small office or for a small network, because implementing on every router the actual routes is really time consuming and can be there, and misconfigurations can occur, therefore administratively hard to cope with it. Meanwhile, on the other side, the dynamic routing uses more bandwidth, more CPU, uses CPU, but there that's from the source to destination, the path can may be different, and the really advantage of it that it adapts to a topology, changes. Therefore it is more advisable to use at larger organizations. So why does it use, for example, more CPU? Is quite simple, that the dynamic so at the static routing we are adding the networks manually. Meanwhile at the dynamic routing they are having a map of the whole topology, and to process, I mean, these routers are sending updates to each other, therefore they are using bandwidth because they are using these updates. Meanwhile no updates sent on a static routing, and because these updates should be processed by every unit that receiving it, they are using CPU. And of course at dynamic routing we are talking about algorithms like the calculating for the best path based on the GSCA algorithm, or don't know how it's spelled out correctly, but it uses also CPU to calculate the best path actually, but I believe the other uses as well. So I would say basically these are the advantages and disadvantages. Classful and classless routing illustrated on concrete examples. I talked about this in previous examples. If we would like to visualize it, classful routing means that, imagine there we have a router here, here, here. Let's say we have a host here and we have a host here. So what's going to happen? This is connected to this one, 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 and let's denote them host 1, host 2, this will be R1, R3, R2, and this is the basic topology. And what do I mean on the classful? It's really simple, that here we are having a /24 class, here we are having a /24 class, here we are having a /16 class, and here we are having a /16 class. No, that's not a B, that's a 6 /16 class. The classful means that, for example, when R1 will send an update to R2 or R3 send an advertisement update to R2, then R2 will update its routing table that what networks they are knowing, and these advertisements will simply add the IP addresses, because at classful from the first octet of the IP address the network could be calculated. So classful addressing means that the whole network should be classful. That means the subnet mask can be /8, 16 or 24, because based on the IP address these networks will be calculated. So network with classful in this case that I wrote, because here we are having the original subnets, so in this case the host 1 can speak to host 2. But if, for example, if we change this to 30, then there will be a problem with this router, because it does not support this subnet mask by default. So this is the classful, and the classless is of course rewrite everything, but having, for example, here 3, 1, 2. So there we can simply rewrite everything, because classless means that the router, during the router advertisements, will also include the subnet mask. Therefore the receiving router will be able to update its routing table, because it also receives the subnet mask on which the network came in. So there we cannot calculate the network from the first octet, because I believe we can have /1, therefore it's impossible to /1 subnet mask, therefore it is impossible to calculate the network. So basically that's the differences between them, and if they need an example, then this is an example for that. What else do we have? A routing table, the structure, content, functions, and actualization of routing table, characteristics of routes. So okay, characteristics here, of course you can come up that, for example, how a routing table looks like. There is an entry, there is the first notification that how the routing was learned, so for example directly attached, or learned through OSPF, or statically or dynamically. And that's the first. The next one after this is the destination address, where we should forward, I believe, and then there is a metric, or there is a metric or bandwidth or cost, and for calculating the best path, and I believe that's all. Oh, of course I believe the interface on which it came in, so actually knows everything. So basically that's a routing table entry. Maybe I missed something, I don't know. Here the important is that how they learn these entries, as I said, dynamically, for example, or etc. And the metric or the cost or the bandwidth is really important, because the different routing protocols are using different metric or way to determine the best path from a source to a destination. So the routing table simply helps the router to determine to which direction the packet will be forwarded. The aim of the quality parameters describing the different routes, metric, and administrative distance. So as I said, we have, for example, metric, and for example, the RIP version 1 and 2 uses the hop count as a metric, and if I remember well, there the 15 is the maximum hop count. That means if the hop count or the metric reaches 0, then it will be discarded. The packet will be discarded. And the administrative distance is really important, because imagine that we are not using a single routing protocol but multiple. Therefore there can be passes from a source to a destination, or multiple passes. For example, imagine that we have 3 routers, one here, one here, one here. They are connected together, I believe, and we don't need the others. So here comes the traffic and here it will go out. And for example, the traffic can either go this way or the traffic can go either this way. For example, if we have multiple routing protocols, for example, imagine that this will be a RIP version and this will be an OSPF, because OSPF uses bandwidth, RIP version uses hop count, therefore it can be possible that they are going in two different passes, even though here it seems longer than go this way. So the administrative distance is the solution here, because the administrative distance means the trustworthiness that simply defines which is more trustable. And for example, if something is directly attached, then the lower the better. If something is directly attached, then it's 0. The static root is 1, and the others, I believe, starts from 100. So if there are two routing protocols that goes to the same destination, then the administrative distance will decide which path will be taken. Examples for simple and composite metrics, I don't know what the composite. The simple, of course, is the hop count, for example. The concept of default route, default gateway, the configuration and operation. I don't know what we have to talk about this. Of course, the default gateway is when you are sending a traffic and it will be passed to the router, and the destination is on another network, therefore it is passed to the default gateway. And the default route is almost exactly the same, that you would like to send something, then because the default route, it will be routed out to the default route, so it will route out to a specific direction. So I believe that that's all about this topic, and yeah, I don't really care if I said something wrong. Don't forget to subscribe.